Look at an empty city. Buildings standing, windows broken, no people. This is not ancient history. This happened within a human lifetime. In 1986, a nuclear reactor failed. Not slowly, suddenly. The explosion released massive amounts of radioactive material into the air, soil, and water. What followed wasn't just an industrial accident. It was an environmental shock. Radiation doesn't behave like smoke. You can't smell it, you can't see it. But it binds to soil, plants, and living tissue. And it stays. Now let's look at the environmental impact. Radioactive particles settled onto farmland, forests, rivers, and lakes. Soil became contaminated. Crops were destroyed. Animals absorbed radiation through food and water. Large areas were declared unsafe for human life. This wasn't about days or months. Radiation alters ecosystems for decades. Some radioactive elements decay quickly. Others persist for generations. That's why land around Chernobyl is still restricted today. Now here's the part most people misunderstand. Nature didn't stop. Plants returned, animals returned, forests expanded. But this doesn't mean the environment recovered in the human sense. Ecosystems adapted to absence of people, not absence of radiation. Wildlife populations increased because hunting, farming, and construction stopped. At the same time, genetic damage, abnormal growth, and long-term health effects continued beneath the surface. This contradiction is important. Chernobyl showed that environmental recovery is not the same as safety. Now zoom out. The disaster reshaped global thinking about energy, risk, and land use. It forced governments to ask hard questions. How do we measure long-term environmental risk? Who pays for damage that lasts longer than political cycles? What happens when technology fails at scale? This is why nuclear accidents are not treated as local events. International bodies such as the United Nations, through agencies like the International Atomic Energy Agency, monitor radiation, manage exclusion zones, and establish global nuclear safety standards. Their work is based on environmental data, long-term monitoring, and risk assessment, not headlines. Chernobyl became a case study in irreversible impact. Energy decisions affect ecosystems. Ecosystems affect health. Health affects economies and migration. Before we end, zoom out one last time. Chernobyl teaches a hard lesson. Some environmental damage cannot be cleaned up. It can only be contained, monitored, and avoided in the future. Environmental science exists to evaluate these risks before they become permanent, to weigh benefits against long-term costs, and to prevent disasters whose consequences outlive generations. In the next episode, we'll examine another major environmental case study, where human technology collided with natural systems and produced a very different kind of damage. This series is part of the Learning Studio, where real-world disasters are studied not for shock, but for understanding. This isn't about fear. This is about responsibility.